This video is about two different types of energy: kinetic energy, and gravitational potential energy. So kinetic energy is the energy of an object that it has due to movement. So if an object is moving, it has to have kinetic energy. We define it mathematically as 1/2 mass times its velocity squared, where mass in gravitational potential energy is the energy an object has due to its position in a gravitational field. In other words, how high it is above either the earth or from the floor, that would be gravitational potential energy. And we say that this potential energy is equal to the mass of the object times its the acceleration of gravity times exactly how high it is above the ground or the earth. So let's calculate the gravitational potential energy of a person. So if a person who is 70 kilograms climbs 5 flights of stairs, they have a vertical height above the ground of 20 meters. So if I wanted to find this person's gravitational potential energy, I would say that potential energy is equal to the mass of the person times the acceleration of gravity times the height. So their potential energy is equal to, 70 kilograms times 9.8 meters per second squared times 20 meters high. So it's important to remember that it's just the height from the bottom to the top. It doesn't matter that he took this long path to get there. It just matters that he's 20 meters off the ground. So if I do the math, 70 times 9.8 times 20 is equal to 13,720, and we measure potential energy as we measure kinetic energy in joules. So this person has a potential energy of 13,720 joules. And so this energy that the person gained in gravitational potential energy by climbing these stairs had to come from somewhere. And so in this case, it came from the amount of work that the guy did to get to the top. I'm sorry, that's misleading. The amount of work that he did to climb those stairs. Alright? So the work in this case is equal to the gravitational potential energy that he gains. And so it's important to remember that according to the law of conservation of energy, energy cannot be created or destroyed. It's simply converted from one form to another. Okay? So in this case, by doing work, the guy converted work into potential energy. And so we can use gravitational potential energy and kinetic energy to solve for problems that we had in the past. So, for instance, if I wanted to know, say this guy jumped off, and I wanted to know what his velocity was when he got to 10 meters above the ground. I could use kinetic energy and potential energy to solve that. So, if I know that he started with potential energy, because he started from the top, and as he falls, that potential energy is going to be equal to the two types of energy he has. The kinetic energy due to his velocity at 10 meters off the ground, and his potential energy due to the fact that he's still 10 meters above the ground. So this would be potential energy final, final, initial. Okay? So if I do a little substitution, so mgh initial equals 1/2 mv squared final plus 1 mgh final. Okay, I see that mass is in every term, and so mass cancels out, as we would expect, because we wouldn't expect a more massive object to fall more quickly. That's just ludicrous. So let's see. And we're trying to find this velocity here, so I'll isolate that term. Gh initial minus gh final divided by, or times 2 divided by r, or times 2 times the square root. Okay, so I can factor out a little bit more. 2g h initial minus h final gives me our velocity final. I'm going to plug my numbers in now. So 2 times 9.8 meters per second squared times our height initial was 20, our height final was 10. That'll be in meters. I solve for our final velocity. 2 times 9.8 times 20 minus 10 square root, and I get a velocity final when he's at 10 meters of 14 meters per second. So what if we take this problem one step further and we solve the problem for when the person has gone all the way to the ground? So in this case, his potential energy is now completely kinetic energy because he has no height. So we know that his potential energy initial that he starts with is going to be equal to his kinetic energy at the end point. So I know that potential energy is equal to mgh, and his kinetic energy is 1/2 mv squared. In this case, that he'll have some final velocity. I see that mass is in both terms, so I can cancel it out. I can do a little algebra and solve for this. So I see that 2gh is equal to our velocity final. So I can say that 2 times 9.8 meters per second squared times his height, which is 20 meters, will equal our final velocity, which is 2 times 9.8 times 20 square root 19.8 meters per second. Okay, so it's actually easier to use potential and kinetic energy to solve a lot of these problems, as you'll see in future lessons.